must not say the Saturday must come. You always get tired over the weekends.
Oh,
You,
no, I want Friday to come. Because by Friday, everything will be over.
yeah,
And everyone will be gone.
Yeah,
and
it's
then
done.
we'll forget about you.
It happens, eh?
No, we
Yeah,
won't
but
forget about you.
no, but it always feels so empty when you guys leave, eh? You have no idea. We look so lost. We look so lost. We don't know what to do with ourselves. Okay.
I just hope that I can remember it. Yep.
No, 11. 12:40. Okay. He wants to start now, so he said in the yeah, in the break.
Good morning, everybody. I just want to take this opportunity to welcome everybody to the final colloquium of our program. I think this is the moment we have all been looking forward to. And I would also want to welcome our colleagues who are joining us via video streaming. We will start with our proceedings, formal proceedings at 9 o'clock. For now, I just want to tell you what is going to happen. I just want to remind the scholars that your presentations are going to be judged, and you are going to be given 20 minutes to do your presentation. 15 minutes is for you to present your work, and then there will be 5 minutes of questioning, and I'm going to be very strict in terms of time. You remember our device there. When you have 5 minutes, I will switch on the yellow one. When the yellow one goes on, you should know that you have 5 minutes. Then when the red one goes on, we have to stop. Right. So it's going to be like that. So I want you to be ready for that, and please make sure that you stick to time, and I don't have to stop you. Then there will be questions. We'll take questions from the floor, and then we'll also take questions from our colleagues if there are questions. Priscilla will advise us if there's any question from outside. So I hope those of you who are going to start with the presentations have loaded their talks. And if you have not and you're later, you can do it during tea break. So for now, I'm just going to pause to wait for the next speaker to come. I'm the first speaker to come at 9 to start their presentations. Krista, do you have something to say? All right.
Yes, here it is. Here it is. Hi, how are you?
I'm good, but there was a mistake with the presentation because we didn't want to switch to order.
It's a bit late now.
But we can, I'm the basis for what he's talking about. This is
Oh, is it? Okay, I will tell.
the only thing was that because usually I got questions that usually offer it because so we thought that we could get the questions in the end after both of our presentations. I mean, it doesn't have to be like that. It was just
Okay.
a question if it's possible.
Okay, I will inform Martin. I'll let Martin know.
Okay, so we stay.
You can stay.
Priscilla, you have received Andres' email. Who is the EASA colleague who is here?
He's not here yet.
He's not here yet.
No, he's only arriving this afternoon. The microphone is off. It's on. How do we switch it off? It says push, but then I. Oh,
wish.
Okay, colleagues, um, it is 9 o'clock. We're going to start with our first presentation. And the first speaker is from Team 12, and it's going to be Mayank Prakash, and he's going to talk to us about, I'm not going to read out his topic.
Yeah.
Okay, Mayank, it's over to you.
Thank you, sir. Good morning, everyone. I am Mayank Prakash from International Institute for Population Sciences. I am a PhD student there. And for this final YSSP colloquium, I am going to present on understanding domestic water consumption, management, and socioeconomic implication in informal urban settlements, the case of Mumbai. This is the outline of my presentation. Before going in detail of my presentation, I would like to give some context of the study. As we all know that water is a basic human right and it has direct implication in terms of health, economic returns, and social gains. As we all know that around 700 million population worldwide lacks access to safe and adequate drinking water. So World Health in 2002 recognized that if we provide access to safe drinking water at the household level, and if we can trap the household management practices, we can avoid the prevalence of diseases. So this is the main rationale behind this study, and the research question amidst this background is to understand what is the level of domestic water consumption in urban slum households, how water is managed at the household level, and what socioeconomic implications these water management and practices have. So these are the three main objectives of my study. First one, to assess the quantity and the quality of water supply at the household level. Second one is to examine the domestic water management pattern among the slum households. And third is to identify socioeconomic impacts of current patterns of domestic water consumption. This is my study area. This study has been primarily conducted in the slums of Mumbai. For the administrative purpose, Mumbai has been divided into 24 wards. However, we have restricted our study to 2 wards, where it's called M East Ward and M West Ward. These wards have been selected with some rationale because in these 2 wards, more than 65% of the population lives in slums, and they also perform very much poor on the human development indicators. We followed this sampling procedure to select a 600 household sample, and we followed the stratified random sampling procedure. Basically, there are 4 types of slum settlements in Mumbai, depending upon the land ownership. There are private slums, state-owned slums, then municipal slums, and non-notified slums. We selected 2 non-notified slums in order to bring the heterogeneity in the population. The study is primarily a cross-sectional, and we conducted a survey on 600 households, and the data was collected through semi-structured schedule and interview schedules. And for the analysis purpose, we have used principal component analysis, cross-tabulation, regression analysis, and the correlation. Now moving towards the results, as the first objective was to assess the water quantity and the quality in the slums. This graph shows that first we try to assess the water consumption at the household level as per the recommended standards. So we find that 67% of households receive water consumption as per the recommended standards of WHO. WHO says that water consumption should be per capita per day around 50 liters to maintain intermediate level of hygiene and aversion of disease. However, Mumbai Municipal Corporation claims that they provide around 100 liters of water per day, but when we did our analysis, we find that only 27% of households receive this type of water. As per the Indian Standard Bureau, it should be around 135 liters in low-income group communities. And as slums are the low-income group communities, only 5% of the household receive this type of water. So what is the average consumption of the household? We find that a household in slums receives 315 liters of water per day, but the per capita per day consumption is only 17 liters. Then we bifurcated this analysis in terms of notified status and non-notified status of slums, and we find a huge differential. We see that those households who are in non-notified slums, that are illegal slums, there are only 207 liters of water consumption per day, but in notified slum households, there is 340 liters. And this has repercussions on terms of per capita. Like in notified slums, household per capita per day consumption is twice more than the household who are in the non-notified slums. So we try to identify that what is the exact level where households receive water. So we find that, sorry, why is getting back? Yeah, we find that majority of the household receives 46% of household receives water within 200 to 400 liters, and 70% of the households receive water below 90 liters per day per capita. We find substantial differentials in terms of slums. We find that in Lal Dongra, the per day household water consumption is 394 liters, whereas it is lowest 159 liters in Sanjay Nagar. This Sanjay Nagar is non-notified slum. Similarly, we also find systematic variation in terms of per day per capita consumption. It was highest 109 liters in Vishnu Nagar, whereas it is lowest 32 liters per day per capita in non-notified slum in Sanjay Nagar. So we try to assess what are the factors that determine the water consumption at the household level, and for this purpose we run regression analysis. We followed least square regression analysis, and we run 3 separate models. In the first model, we try to assess the impact of education, and when we run it, we find that education is significantly positively associated with the household water consumption. But when in the second model we introduce wealth, we find that the role of education becomes non-significant and wealth becomes important factor. But when in third analysis we introduce factors like water supply, like source of water, tap water, and duration of water supply, all these factors become significant, and the factors like education and wealth becomes non-significant. So in this context, it is important to highlight that water consumption is mostly determined by the water supply factors in slums. Then we try to assess the perception about water quality in slums, and we find a systematic pattern in the reporting of water quality in the slums. And the figure shows that reporting of water quality was mostly bad in terms of taste, color, and odor in monsoon season. However, they are far much below reporting in summer and other seasons. We also constructed a composite water quality index at the household level, and on this basis, we find that 18% households in slums receive bad quality of water in all these seasons. We further bifurcated the reporting of water quality, and we find that in three slums, reporting of water quality was was more bad. Like in Cheetah Camp, Anna Sathe Nagar, and Sanjay Nagar, household reported from 25% to 37% to receive bad water quality. However, it was far more lesser than in other slums like Ghatla, Chadri Nagar, and other slum areas. We also assess the mean days of bad quality of water a household receives during various seasons, and we find that mean days of bad quality is highest 6 days in a month in monsoon season. So water quality is really a major concern in the monsoon season. Secondly, we try to assess how water is managed at the household level, and for this purpose, we identified 13 indicators that are important for the household water management. And when we did our analysis, we find that there are substantial proportion of population that they follow less hygiene water management hygiene practices. Like as per the recommendations, water should always be stored on the on the slabs or on the stand, but only 66% of households follow this practice. It is also recommended to have mouth of the water container to be narrow so that the contamination can be prevented, but only 26% households follow this thing. Container must have spigot, so can they draw water, but only 25% households have this type of container. And the most important thing was that how they draw water from the container. We find that only 12% of the household follow the recommended practice of drawing water through long handle mug, and it was observed that almost around 80% of the household draw water by sinking their glass in the container. So it had direct implication on the water contamination. Most of the households do not clean their water container daily, and only 9% of households reported such. Although we know that water is a major concern in terms of quality, but only 19% of the household follow this practice of water treatment. So there was systematic reporting of some of the indicators that are substantially low in households. We try to construct and to show that how these management patterns vary across the slums. Then we find that in 4 of the slums like Cheetah Camp, Vishnu Nagar, Mahatma Phule Nagar, and Lal Dongra, around 40%, 50% of the household reported that they follow the high water management practices, but it was substantially low in Sanjay Nagar and Anna Sate Nagar, where 23% and 26% population reported following high water management practices. We try to identify the factors that affect the household water management practices in terms of socioeconomic condition, and we find that factors like age of the respondent, education, and wealth were the important factors that determine the household water management practices. As from the figure, we can see that those women who were of younger ages were more likely to practice high water management practices as compared to women who were over 45 years old. Similarly, those women who have education level up to high school and above, 38% of them reported to follow high water management practices as compared to 28% of non-literate women. Illiterate women. Similarly, those households who fall into the rich quintile, they followed 43% of them followed high water management practices as compared to those households who follow in the poor quintile. At the same time, other factors like source of water, water consumption, and water knowledge also appears to be the important factors. But when we run this generalized order logic regression model, we identify only 4 factors that determine the household water management pattern, and that is age, caste, wealth, and water consumption. Older women were less likely to practice high water management practices in households. Those households who belong to general caste and fall into the wealth quintile, they have the high water management practices. In the last section, we try to identify the socioeconomic implications of water management and consumption patterns in slums. We find that the major responsibility of household water collection primarily lies on the women, and we find that almost 93% of adult women are responsible for water collection as compared to 66% of male. The mean duration of time spent in collection of water is almost around 2 hours per day. Then we also followed on the reporting of water-related incidences, and they are very much prevalent in slums. Like 43% reported verbal abuse, 37% reported they have quarrel or fight. 19% of women also reported to have eve-teasing incidences at the source of water collection, whereas the proportion of sexual violence was very low. It may be because of the social desirability, they don't want to discuss all these things. So we try to assess the frequency of these incidences, and we find that this is quite prevalent in the slums, and 51% of the household report that they face such a type of problems on some time basis. We also asked that whether they have faced this type of problem in the last 3 months. So 38% of the population reported that they have faced similar type of problems in the last 3 months. Now we identify who are the members who have faced this problem. So we find that female are the most vulnerable population who face such type of problem. 78% of the population female reported that they face the problem. We also assessed that whether they feel any type of domestic violence at the household level. So we find that in 25% of the household, women reported that they face some type of domestic violence related to water collection and management practices, and it was the frequency of reporting was 54%. That is sometimes. In 8% of the households, children miss their school because of the water scarcity at the household level, whereas in 14% of the households, members miss their workplace because of the water scarcity. Then we also find that whether women are discriminated in the household water use, then around 20% of the women say that they are discriminated in the household water consumption. So these are wider implications. When we come about when we assess the economic implications, we find that those households who have their own tap, they spend around 41 INR, and shared tap, they are around 34 INR. But those households who do not have tap water consumption, they spend around 267 INR per month. So it's almost around 5 to 6 times more than those households who have their own tap consumption. Based on these findings, I have following things to conclude. We find that per capita per day consumption is significantly low below the recommended standards, particularly in non-notified slums. We also find hydrological apartheid in slums, like domestic water consumption varies significantly across the slums. Domestic water consumption is significantly determined by the factors related to water supply, and water quality is major concern in slums, especially in monsoon season. Household perform some optimal on few of the household water management practices like type of container, mouth of container, etc. Socioeconomic factors are significant predictors of household water management, and we also find substantial evidence of socioeconomic impact of water. The greater burden of household water management practices fall on women, and they are most vulnerable. And additionally, we also find that low consumption of water at the high price, especially in slums that are non-notified. Based on this, we have following policy recommendation that we need to strengthen the water supply system in the slums. We also need to strengthen the maintenance of water supply in the supply system in the slum. We also propose to regularization of the non-notified slums, because if they are regularized, they will be entitled to get water supply and water tap connection. And as the water management practices were substantially low on few of indicators, we propose there should be some scheme for the household awareness about the management practices. However, we have following limitations. We may have encountered the problem of social desirability, because people tend to give favorable answers on the few of the indicators, and while they also tend to under-report some of the indicators. And we also assess this water quality on the terms of perception about the water quality. So if we had considered the actual indicators of water quality, the study would have given more insights. Thank you.
Thank you, Mayank. Can take questions from the floor. Yes, Martin.
Thank you very much for a very interesting talk, and I think it was particularly interesting that you looked at household divisions by categories, which is often overlooked in the literature. So I was particularly interested in seeing that you linked water management and poor water management with discrimination of women and violence against women. So I was wondering, could you elaborate on that? What's the link? What is the cause and effect, or why do you think there's a link between that?
Okay.
Thanks.
I will go back to my slides. As we said, that there are basically three types of water supply in slums. First one is those households who have their own tap. Other one is that who have shared tap connections within 5 to 15 households at one time. And the third category is those households who do not have their tap connection, but they purchase water either from the tankers or for the other households. So as water is scarce in these slums, and women are the primary responsible person to collect the water, so they have certain systems like you have to go in the queue. So there is a numbering system. If you go first, you will have to collect water first. But in these slum areas, as water is scarce, if you go last, you won't be able to get the water. So there is the prevalence of goons who come and they distort the water distribution system. And the greatest burden is felt by the women, because they are weak, they cannot reply, they cannot intervene in between. So they face this type of problem. At the household level, the discrimination is in terms of like that, when women ask that you go to bring the water, but no, men say that no, I cannot go, I have to go to the work. And if they resist, they have to face the problems in terms of violence, because they are beaten, they are chided by the household, they are scolded too. So this operates at the household level. And also there is discrimination in terms of water consumption at the household level, in terms of water sharing, because as men are the breadwinner of the household, they have to go out to the work, so they have to take the shower. So women reported that they compromise their bathing practices, they compromise their laundry practices in order to facilitate their men to go out. So these are the discrimination in the household level. And one more thing about the water distribution in slums, that is very complex. Because like BMC says that they are providing water through the tap connections and shared tap connections, but evidences show that 20% of water supply in Mumbai is being trapped by the illegal workers, like tanker water suppliers, like construction firms, and they distribute water at their own cost. A 35 liters of jerry can cost around 5 to 10 rupees in Indian currency, whereas the actual price of 1,000 liters of water is only 2.25 INR in a month. So we find a huge discrimination of the water. It's a factor. Thank you.
One last quick question and a quick answer from you, Mayank.
Yeah.
Yes, Dave.
Thank you very much. Thank you very much for that presentation. Were you at all also looking at the quality of the water in terms of microbial contamination?
No, sir, I didn't look at the microbial contamination because this is a household survey, so I didn't go for the water sample sample testing. Yeah.
The speaker? If there are questions from outside, my uncle will always direct them to you later.
Okay.
Yeah.
Thank you.
Right. Okay, now the next presentation.
Must I do it myself?
Yes, do it yourself.
Okay.
The next presentation is by Ms. Poshia Mokwena. She's going to talk to us about application of electrical resistivity method to identify suitable areas for drilling shallow wells in coastal areas. Over to you, Poshia.
Good morning, everyone. My name is Poshia. As I was introduced, I'll be giving a talk on the use of the application of electrical resistivity method to identify suitable areas for drilling shallow wells in coastal areas. My outline is as follows. I'll start off with the research question, and then I will close up with the future works and recommendations. The question that I hope to answer at the end of the study is that, to what extent can geophysical methods such as electrical resistivity be used as a reliable method to identify suitable areas for shallow wells development? There are many geophysical methods such as the magnetic, electromagnetic, ground penetrating radar methods or gravity methods, but specifically this one, the electrical resistivity method, is more useful for, it's been widely used in groundwater exploration studies, and it's because of its capability to identify potential groundwater areas. So I chose this so that's why I chose to use this method in this area, and again, it's also cost effective and there's less time consuming, and also it does not damage the ground when you're doing the survey. And to add on the area that I'm working on, there's not a lot of geophysical studies that have been conducted in that area. So there's a limited knowledge on the use of this method. Hence, that takes me to my aim that I want to improve the knowledge of the use of geophysical method in identifying suitable areas for drilling shallow wells. So I then formulated the following objectives. What I want to do, I want to assess the areas for drilling these wells in a coastal environment, because I'm working on a coastal area, and also at the end I would like to assess the role of groundwater and in the hydrology of the catchment. This is my study area. This area where the survey, the geoelectrical resistivity survey, was conducted in Henningness catchment. Is an area that is found in the Western Cape province of South Africa. The catchment is characterized by different water bodies, flays and pans, and also rivers. And previous studies who have done groundwater exploration works around 1991 and also in 97, they have reported that the area has, it's characterized by saline water, which is not suitable for human consumption and also for irrigation, only for those crops which can tolerate salt. And another thing, there's an area, in some parts of the area, it was reported that the shallow aquifer have fresh water, meanwhile the deeper aquifer has saline water. So the thing, there's no scientific evidence on what is the cause of the salinity in deeper groundwater. So it could be because of the seawater intrusion, or it could be because of the rock-water interaction, or it could be because of anthropogenetic factors. So as I've said, that there's no scientific evidence, so that's why I would like to do this study. And for me to do that, so I need to drill monitoring wells, and to be able to get those wells, you first have to know where to drill those wells and then where water is, so you can be able to drill, and then so you can be able to sample the wells and then characterize the water quality in the area. The geological setting of the area is characterized by sandstone of the Tail Mountain group, and also the shales of the Bockerfeld, and also
the shells of the Malmasberry groups. So it's important to understand the geology of the area because that links with groundwater. Is very related to groundwater. You can know like what type of aquifers are in the area based on the geology, and also this will help in the interpretation of the geophysical images because different rock materials have different resistivities. So in knowing the geology in the area, then you can interpret well your images that you're going to get from the results. Data collection method, I use the 2D electrical resistivity imaging using the ABEM terameter SAS 1000, 4000 instrument. So that basically this instrument, it comes with the the multi-core cables. And how it was done, the procedure, you line the cable in a straight line on the ground, and then you hammer the electrodes so that you can transfer the electrical current to the ground. Then you can read the subsurface characteristics, and then it sends the information to this it sends the information to this instrument in the form of a text file, and then later on you can use a software to read that and then create the models. A total of 11 geophysical surveys were conducted, 5 in the Studentals Flay, and then 3 on the Fourth Flay, and also 3 in the V-strip. So these actually are 2 geophysical lines. So the yellow lines are the GPS coordinates that were done on the line, and then most of the lines, the longest is 240 meter long, and the shortest is 160. So this one, this line are intersecting in the V-strip. This is in the V-strip. We also did, and this is one geophysical surveillance. So if you can see the cable, So this is, if you can see, this is how we line the cable on the ground, and then so we have the electrons along this cable, which are connected to the instrument, and then that sends the information. And then also in some areas, because the area is not level, so sometimes we have to take elevation. So this is the equipment that we use to take the elevation. It's called the dumpy leveling. We were taking the elevation along one of the geophysical survey in the Fourth Flay area. So this is the meter stick. So one guy will stand on this side and the other guy will stand on the other side, and then you read and then you record the different elevations, and then later on you need that for your models to understand the slope of the ground. The software that was used, the data that was collected on the field, it's then you can use the resistivity inversion model to interpret the results, and then the software allows you to delete bad data points, such as this. You can be able to see bad data points, then you can remove them from your data. So these basically are these ones here. So these are the bad data points, and you can delete those. It also allows you to reduce errors by just simply dragging this line to where to how much you want to reduce the errors for. The software at the end, what it gives you 3 models. It gives you first the measured resistivity apparent to the section, the calculated apparent resistivity, and also the inverse model resistivity section. So the inverse model, So this one basically it represents the true subsurface that you collected on the ground, because it uses this model and then it calculates to give you the true reading that matches the ground where you did the geophysical survey. And we also did a hydraulic injection in order to understand, in some parts of the areas, not in all of them, in order to understand the subsurface material. So when we interpret the results, we can be able to relay on what the geology of the area was. In Fourth Flay, when we did the hydraulic injection, we got, first at the surface we have arsenic clay, and then it changed to clay, and then fine clay, and then at 2.8 meters, we had the sandy clay again, and it was gray in color, and then we had marine deposit, and it was very salty when we tested the water and those sediments as well. And then at 5.6 meters, we also got fine clay again, and then we could not penetrate over 7 meters, and we assume that we had hit the bedrock, so that's why we couldn't get any more materials from the ground. How the hydraulic injection works is that you you pump water from either a tank if you're not close to the lake, and then what it does, and then you suck the materials out using the water pressure. Then it can along when the material comes like this, then you can be able to note the different in colors and then also the texture of the soil, and then you can record that. My result from the from the analysis of using the software, these are the results that I got for the fourth lay. Basically, this is the horizontal distance on the ground from, it was 224 meters, and then this is the distance below the surface, it was up to 20 meters deep. And then this is the scale of the resistivity. So resistivity will increase in this direction. So this is the low resistivity, this is high resistivity. Inverse, that means this is high conductivity and this is low conductivity. So what we got here, we get 4 layers. There are brackish water saturated layer with the high conductive layer. And we have the sandstone formation because of the resistivity, because sedimentary rocks, they have low resistivity from 10 ohms up to 1,000 or less than 1,000. So this, we take it as is the sandstone. And then this portion here is the weathered material of the sandstone, and then closer to the surface, this is the sandy or the more permeable materials. So in this case, I would suggest that drilling should take place at this position here in the water saturated layer. And also here just to confirm the presence of the sandstone, and then also here to know the difference of the permeable material and also the water saturated layer. And the other geophysical survey on the fourth lay, the other one only showed one layer, basically the conductive layer, which is the brackish water saturated layer. Based on the resistivity values, they are below 2. And then these blue lines, they can be attributed to the bedrock, but we could not see the bedrock because this was limited up to 15 meters deep. If we can go deeper, then we can be able to see the bedrock. So we assume this is the weathering material from the bedrock. So here we can drill, because this area, it's more like, it's the same, so we can only put like one borehole here just to confirm that, and also to check the water within this area. And the last one, the fourth lay, we have this, we also have similar to that one, we have the water saturated layer with the conductive layer in blue, and then we've got the shale formation, and then this might be the weathered materials from the shale formation, and then this is assumed that it could be a layer of fresh water or a poor clay layer. So we need to drill here as well to confirm that, and also to see if you can put a borehole in that area. In the third side, in the drift, the Vis drift, we also did 3 surveys in that area, and the results are as follows. Okay, so we also have like similar like the previous surveys that we did. We also got the brackish water saturated sediment layer here in blue, and then we have the shale formation, a little bit of the shale formation. So we assume that this is part of the shale formation, and then this blue is interpreted as a fresh groundwater saturated layer or a clay poor layer. It could be a fresh water because maybe of recent recharge, or because this layer and this layer are different. This is at the deeper level, this is closer to the surface. On the third one, we only have 2 layers. We only have the shale formation, and then on top of it, we get the water saturated sediment layer. In the student as play side, we also, we did 5 geophysical survey lines, and then these are the results. In the first one, we also have a similar layer. We've got the sandstone, and then we've got the water saturated layer here. And then we might have, so we believe that this is separated by the fault. As I've shown in the geological map, the area has lots of faults and fractures, so this might be the fault in that area, because it was repeated also that on the student sphere there's a mega fault running through. And then this might be the sandstone. And on the second one, we also have the conductive layer, which I believe we can drill somewhere here because it's the same layer. And then at the edges, we have the sandy, more permeable materials and a little bit of sandstone. So if you can stretch this line maybe up to over 192, we can be able to see the extent of the sandstone in this area. And in zone 4, we also have same results. We've got the water-saturated sediment layer. We've got the sandstone, and then we've got the weathered sandstone. And then this material can be from, maybe this is the highly weathered material of the sandstone. So we need to drill here. And then we need to drill as well at this point, just between 160 and 192 meters. And also just after 64 here to confirm the layer, and then here to understand the water in this area, because this is a water saturated layer, so there is water in these blue areas. Okay. And this is also the same layer as also a water saturated layer in the Sudanal Strait. And in conclusion, I concluded that, okay, the electrical resistivity method was able to characterize the subsurface layers and their properties, and also the geoelectric images reveal 4 resistivity subsurface layers: the sandstone, the shale, the water-saturated layer, and also the weathered material, and also the layer of groundwater, of fresh groundwater. And therefore, it was successful in locating the potential areas for well point development. The limitations.
Thank you, Portia. Sorry, can you thank Portia, please? Questions, Maria.
Thank you, Portia. That was really interesting. I have never looked, I think, at the resistivity of layers before, but I was wondering why resistivity is correlated to water quality. I guess why are you looking at that particular variable? And my second question was, I've been reading a little bit about how they have plans. One of the layers there was shale and hydraulic fracking for energy. So that's going to probably occur in the near future in the Karoo biome, and I was wondering what your opinion was about how it would affect the other geological layers and the water quality.
Thank you, Maria, for the question. The first question, the resistivity is related, I think it was how resistivity is related to the geology, right? It's related because different geological material have different resistivities. So, and then also the resistivity depends on the water content and also on the quality of the water. So if there's more dissolved salt, and then the resistivity will be very low. Then if the water is fresh, then also the resistivity will be between from 10 to 100 ohms. And in terms of the fracking, I think maybe we can discuss that during tea break, if you don't mind.
Another question? Priscilla, do you have something? You have a question.
Now that you've identified the geophysical properties of the area you're interested in, are you planning to carry on with the drilling, or is your result going to inform the decisions in future studies?
Thank you, Dr. Priscilla, for the question. My next step from here, I will have to go back to the field because this is part of my PhD, so I needed to do this so I can identify the areas to drill the well, so I can be able to sample the groundwater and then understand the quality. Then, with that information, characterizing the whole catchment, the geochemistry of the catchment, then I can inform decision making on this is the water that we have in this area, and then they can come with a better strategy on how to protect it and how to manage it. Thank you.
From Professor Charles.
Thank you for the great work. I was just wondering, have you been able to validate your model? And if so, how have you done that?
Thank you, sir, for the question. No, I have not been able to validate them. So I will, as I've said on my future work here, that I need to go back to the field and then do jetting and also hydraulic injection and also drilling at some parts to be able to validate the model if that what they said is really what's on the ground. Thank you.
Can we thank the speaker? And then our next speaker. Our next speaker is Mr. Alois Katiti. He's going to talk to us about satellite-based estimation of evapotransportation of the green scheme irrigation projects in Namibia.
Good.
Thanks, Alois.
Good morning, everyone. As introduced, my name is Alois Katiti, and I'm from University of Fort Hare, and I'll be talking about satellite-based evapotranspiration on the green schemes. And evapotranspiration basically is the same thing with water. We're dealing with water, but then we try to use about a bit fancy words, because Mayang was talking about water as slums, and she was talking about looking for water. Now we're trying to determine how much water are we having losing from the ground using the satellite systems. And so that will be basically my outline of the presentations. Firstly, I want to introduce you to climate change and variability. It's basically not the first time we hear about it, and it has been there for ages, and it is still there it will still be there for some of the years to come. And basically what we are saying is that climate change is basically affecting our production in different forms, and that's basically atmospheric moisture, precipitation, temperature, and most importantly, it has a big influence on the hydraulic cycle, which is the main driver of the earth systems. So basically what I'm trying to do here is trying to introduce from where it is coming from. It has been there since the 70s and much more from there. And when basically what we're trying to do here is climate change contributes basically to access to water and food security, and it has a lot of problems like drought and famine. And these are basically what has been known as things which has been existing, and it's studies which has been done to highlight the importance since those days. So what we're trying to say is it has been a global thing. It's not only in Africa. And as you can see, I'm basically down southern part of Africa, and we could say we get actually two types of water scarcity. The first one being physical water scarcity, and the second one economic scarcity. And about physical scarcity, we try to say like there is water is scarce in terms of its availability. The second one, which is the economic, is like we don't have infrastructure to build infrastructure to supply water to the necessary areas. And as we can see, my study area basically in the southern part of Africa is linked with economic water scarcity, which is basically why I'm doing this study of just to see how much water we can apply during this time and whether we can actually introduce this infrastructure. So this is what has been said in Namibia. One of the daily newspapers in Namibia said that Namibia is classified as one of the most risk countries globally in agriculture production due to climate change. So what I'm trying to say here is for us to have something to eat, or for us to have orange juice even, which almost everybody here is quite familiar with, there must be water. So I'm just trying to highlight the importance of water and how we actually, all of us know about and are aware of the importance of water scarcity. So there it is, we have water now. That's the infrastructure we're talking about, economic infrastructure which has been introduced. And simply what we're trying to say here is the green scheme irrigation project. That's why we're going back to the main topic. And we're trying to, introducing this infrastructure, we're trying to look on the side of sustainable irrigation infrastructure, which aims at water use efficiency, because we are trying to move back to the side of physical, preventive things of physical water scarcity once we are trying to attain the economic water scarcity in terms of infrastructure. So basically what I'm trying to do here is I'm trying to link all these processes in terms of environment, how Namibian green scheme irrigation projects, if to succeed, how they have to look at it. They have to look at the ecological side and economic development. That's where we're basically looking at these things, because green schemes are introduced for the fact of job creation, social well-being, food security, and all that. Those are the questions we have been asking. So, but then we don't just want to pump out water and overlook at the environmental side. So we are looking at the environmental side, and this basically all links together. And we are trying to do sustainable development in natural resources. When basically all the initiative comes with Vision 2030, which is aimed at producing enough food for everybody in the year 2030. So why evapotranspiration? And what is it actually, evapotranspiration? Evapotranspiration basically is two words which has been mixed, combined. Evaporation, surface water loss, and the other one, transpiration, water loss from plants. So why are we doing this? How do we justify that we have to do it? It's the second most important variable in the hydrological cycle after rainfall, and plays the most important role in controlling all the water type of the different cycles in runoff, river discharge, irrigation water requirements, soil water moisture, and therefore it's very important when we do irrigation schemes to include it in our water budgeting and planning systems. So what is the problem here? We're trying to increase the productivity of the wave using the limited water resources and land as well. And we say many countries face serious water deficiencies toward the inefficient water use, especially in sub-Saharan Africa, and basically inefficient water use, applying on different times, and so on. That's why we're studying when actually evapotranspiration study, taking you back to when to apply and then applying this type of. So crop evapotranspiration is one of the most important hydrological processes, as indicated earlier, in irrigation and water allocation in the trilands, and especially in the countries like Namibia where the weather is hot. And yeah. So the aims of the study is to quantify the rate of evapotranspiration to inform the national level of irrigation management practices in the green scheme irrigation projects which has been introduced. By doing that, I have a specific objective for that, to quantify using different methods. That is pen method, which is a type of taking as an validation, and it's what's been taken on the ground for. And we need to SEPAL method, which is the satellite model, which uses the satellite imagery to estimate evapotranspiration. And then Penel-Montef, it's a FO model for determining evapotranspiration and the temperature base of Heckref. And the second one is, secondly, I want to determine the relationship between these two methods, between these three methods, basically using the PEN method to assess the relationship with each of these other three methods. And the process produce seasonal and annual ADO maps for references or for management. So that's basically with the SEPAL model, which is going to build up all the seasonal and annual maps for how water is being lost via this process. So basically, this is my study on top of Namibia. And I'm having like 3 sites at the moment, Masare, Sadikongoro, and one in Kalimpesa. And basically, there's stations all over, stations from SASCAL project and stations from Namibia Meteorology Services, and that's where I'm getting a data source. That's my data source, actually. And basically, my data collection and processing, satellite imagery is the path or different places, path and the rows for different locations, which I have downloaded, was downloaded from this. So my first image processing was like downloading an image, and I have to, larger image, I have to layer stacking, subset the image, and then I have to transform the image into NDVI. And later on, I will say how NDVI features into this as well. So SEPAL is the main method which I'm trying to analyze this with. And then basically SEPAL uses, it's about about 18 algorithms which has been run through this model once you use ATRAS modeling. And then SEBAL is the net radiation flux, which basically is an energy system, where we say how much energy goes in, how much energy has to come out. And basically the energy for evapotranspiration is the latent heat flux. So soil heat flux and all sensible heat flux, they are all calculated. So, and basically we use either a model maker of ATRAS imaging software and to determine evapotranspiration using SEBAL method. So these are basically the meteorology data and requirements, what data sets you need for a specific method to use. Then these are the 4 methods I've been using. And these methods, basically, the SEBAL method requires the, where do we go this? SEBAL method basically requires the temperature, solar radiation, relative humidity, and as well as precipitation. It's supposed to be daily. And all the other methods actually, Penamate, however, would be monthly as well, which I use monthly data here, and monthly here as well. And Pen method is daily as well, because it has been recorded daily. Okay, these are simply the different calculations I did. I used the crop watt software, basically, which you have to which you just insert all the data sets of the meteorology services, like the maximum temperature, minimum temperature, and it will give you automatically your radiation versus evapotranspiration using the Penamate model. And evapotranspiration, EPEN is actually the evaporation from the pen itself, and the pen coefficient, which I use Dolenpost, pen coefficient constant. So this is just to illustrate, this is the main method I'm supposed to be using for this, and CropWatt uses this same method which is introduced in this software. And the temperature-based method is actually from Simon Hargrave, which uses, and somehow it is one of the methods considered to be most easiest because it needed less parameters for estimation. So these are my results when with that different methods, except with, I have Penamate here, and I have HICRAF, and I have EPEN, and these are basically monthly, and for 18 months since 2011, January. So I decided to see what does it tell me. I tried to look at it a bit deeper in, and then when I look at it deeper, I have to try to see where do I get the maximum, where do I get the highest evapotranspiration, and it's basically showing that EPEN actually gives us the higher the results here compared to the other two. And then we actually got the maximum from this irrigation scheme, which is Masara irrigation scheme, and the minimum results were actually obtained from Kalimbesi, and which is a rice irrigation project. So simply what I try to do is I try to visually see how it is actually, what is it telling me, and do I have anything to say about it. So I try to see, just to have a time trend series graph, just to see how it actually goes about. And then I had to estimate, demonstrate similar trends over the time, as you can see. And then I had actually our correlation with irrigation which is quite high for this. And I went on to do for all these irrigation schemes. And here I actually saw a very good trend, which shows there is much more quite similar trend of behavior in terms of increase and decrease, and shows actually even the best, one of the good results as well of the relationship, which one can say I can use it as a best fit model to determine the other variable. And here at Kalimbesa Rice irrigation scheme is where we actually have much more of a contradiction between each of the results here. And basically what we did is try to see we have the lowest in terms of the correlation, as we can see from the graphs as well. So this is basically just to highlight using the satellite imagery, the differences. And what I did is I applied NDVI because, we don't have other software here where I can actually use the other. That's why I didn't have it on the table to have several model, which is part of the main study. So I used NDVI. NDVI actually here indicates, where you can see I use false color composite, which means I use the near infrared, which indicate high large vegetation. And when you look at the NDVI, you can see when the lighter the color is, the brighter pixels actually here shows the higher evapotranspiration, but can't be highly quantified in terms. But then we can see from the scale, the brighter pixels are falling under +6. And then the same here, where we can actually highlight the difference here, where we can see the difference here. Here we don't actually have any vegetation going on, and then no evaporation. It's a fallow land, but quite the same area on this side, where we see the pixels are much more brighter, showing against the dull pixels down here that there is much more higher water in the environment, as the water is not in terms of vapor as such, but in terms of availability to plants as well. So I try to say, look at the other side again and see how it actually corresponds to these two images, and then see the vegetation here much more higher and then lower here, and you can see the differences with the imagery as well, how many brighter images we have here. So as we are saying, we have been going through a lot of challenges. I didn't actually get the software, which is ADAS imaging, and I couldn't actually set up the results at the moment, but then I understand we still have a month to go, so the results will be soon as I go back to my university. Yeah, and then as you can see, I use the data sets for crop world. Crop world determines actually how much one can irrigate and all that. So if I could have had those data sets, I could have actually estimated how much water is needed for a certain area and how much water for a system can be applied. And so can I quantify the whole lot of water which is available for the area. So simply that's and I couldn't actually draw much of the conclusion here, but I'm saying very specific methods to be applied. Conclusion assumes relative good relationship exists between various methods applied to estimate. Understanding a relationship is the core of choosing the most simple available technique. Yeah, and from the results, it can be seen that there is no best method, as its performance varies over different seasons as well. But then I suggest, integration of most methods, especially I'm in GIS and remote sensing. I prefer remote sensing. So integration of remote sensing should be the best.
Thank you so much. Can we thank the speaker, please? Questions? Maria?
Hi, thanks, Alois. I was just wondering why you normalized it with the NDVI.
Yeah, NDVI is part of the main in determining the moisture from the and what I did is actually I didn't just normalize use NDVI for that. What I did is I extracted the NDVI and then used the moisture levels of the plants and indicated. That's why I'm saying not in terms of moisture, but in vapor, but in terms of moisture available. That's what the images are showing there. So it shows there is higher quality or higher quantity of moisture around. Yeah.
One last question. Yes, David.
So there's a graph there where you show that it is highest over the year, but it seems to be in the winter months.
Yeah, it is. Yeah, that's what. Which one is that? Winter months supposed to be. Let me quickly go back to
that one from about April, June.
Yeah. The highest you can see it's in about April 11th there, where we can see. Yeah. It's partly starting of the of winter month, and that's where we say it's most possibly it's higher production time, and it's just after the raining season. And what I was saying when I indicated with the vegetation NDVI, I said high moisture content actually is the one which causes. And Evapotranspiration being by different parameters, the heat, which is actually hotter in that time. At start of the winter, we get much more higher temperatures in winter, starting from May and so on. April is still a bit cold, and if it's windy, we know how evapotranspiration works. It's windy, and all those parameters apply to that. And all this evaporation from the pan as well shows the same trend. And then that's what I was questioning that, and in December we have also a different, but then it could be we're talking about climate change. We don't know what that year was in terms of temperatures.
Thank you so much. Can we thank Alois again? Thanks, Alois. Then we'd like us to welcome the next speaker to the podium, who is Shelley Borga. And Shelley is going to talk to us about systemic analysis of the food, water, energy nexus for Free State, South Africa, using dynamic modeling approach.
Good morning, everyone.
Over to you, Shelley.
Good morning, everyone. Making a start. The title of my study is A Systemic Analysis of the Food and Water Energy Nexus for the Free State, South Africa, using dynamic modeling approach. And my name is Shelley Bogra, and these are my supervisors who have guided me through this project. Why am I doing this project for Free State in South Africa? That's the question. So let me start. If we look at the background of Free State in South Africa, we see from the top left corner that Free State lies in the central region of South Africa. It has nearly 67% land as a grazing land in this area, and the other land, out of the rest, nearly 19% is used for food production, which is nearly 3 million hectares for Free State. And this, if you look at the bottom left graph, it indicates the Free State is the highest grain producing region of South Africa. Moving to the bottom right, we see that the major grain production coming from this area is wheat and maize production. And at the top left corner, we see what's the rainfall statistics for this region are. So we see that there is a continuous decrease in the rainfall pattern from the eastern part to the southwestern part. So with such a variation in rainfall and being a major grain producing state for South Africa, Free State becomes a very important component of the agricultural system of South Africa. That's why I'm focusing on Free State. Then again, okay, it's a grain producing state, major grain producing state, but why is it important from the food, water, energy nexus, and what is the problem and challenges associated with the agriculture system? So the reason is that in South Africa, nearly 60% of blue water, that is the ground and surface water, is being used for irrigation purpose. Now, this water, once used, it is not available for any other system, be it power generation, be it domestic supply. So if you have a continuous increasing demand of irrigation, you have its repercussions on the other systems as well, which are part of a broader economic network. So the increasing irrigation is going to be a problem for this kind of a food producing state. So that's the reason I have focused on this state. So the objective of this study is to first understand how the agriculture system in Free State is, what is the nexus between the food, water, energy that is going on between wheat, maize, and other crops that are being produced. once we have that systems view, we can see how the food production actually affects how much of water is being consumed, how much of energy is being required, and how is the land use is kind of changing in this state. So with this systems view, I move forward to the second objective of assessing and quantifying how much of irrigation demand is being created, both in terms of blue water as well as the energy being used for irrigation. The second part is the second objective is to see how much of revenue is being generated per unit amount of water that is going in production. Like wheat uses a certain amount of water, but the monetary worth of wheat, is it actually are you getting that kind of return from wheat or not, or should that water be better used in other systems like mining and the other ones from an economic point of view to generate the best returns for the economy? And the last objective is to see if an intervention like in rainwater harvesting is applied to this system, how we can reduce the energy for blue water demand, and how we can actually change the rain-fed area to inside rainwater harvesting, irrigated area using inside rainwater harvesting structure, and increase the yield in the rain-fed area so that the blue water demand in the other irrigated areas as well as the energy related to irrigation can be reduced so that there is less burden on the other economic sectors in that sense. The boundary of this model does not capture the hydrological component or the other biogeochemical cycles like phosphorus or nitrogen or carbon, which may become very important components. So this is more of what is actually happening on the field, how human beings are actually doing on the field. So this system is a very small part. It is not linked to the higher physical processes. The another limitation of this work is that if there are changes in the price of commodities, then their agriculture potential also changes. So that leads to a change in the land area use as well. So that land area use will actually transform into water and energy change as well. But this model does not capture that point, so that is definitely a constraint for this work. The other constraint is that there's lack of data available for how much of changes happen in the rain-fed area as well as the irrigated area, both in terms of how much of yields has increased over time and how much of total land use has changed. So this is another limitation of this work. And also, I have not incorporated the indirect consumption of water energy and other materials like phosphorus, chemicals, and all that thing in that, because this is, again, make this model very big, and 2 months is a really short time to do that. The scope of this model, as indicated in the objectives, is that we are looking for this model helps us in selection of those crops which optimizes the water use in that is available to this region. The other good aspect of this study is that it is a generic model, so if you need to put in just the right values for the variables to run it for any region, so it can be implemented for any part per se. The third one is that this model is very flexible, so you can always integrate other interventions like technological innovations and the introducing of specific varieties of plants which can actually increase the yield and lead to more water productivity and more economic revenue. So that kind of interventions can always be included in this model. Further, it might serve as a water allocation tool for the Free State. So I'm going to present the systems perspective of this model now. So before I go in, I need to mention that the system dynamics modeling was performed using the Vensim PLE software, and I have included only 3 crops for the region, wheat, maize, and potatoes, because they are showing the major irrigation. That's why I can include both the rain-fed and the irrigated areas for these crops, and hence I've included that. Further, in the bottom, I'm showing the kind of data that was used for building this model. It included area, the production, the yield, the revenue for the crops, as well as the crop water requirements and the energy use. So it is trying to capture a food, water, and energy linkage of the agriculture system. In my last presentation, I presented this picture of the agriculture network, but my model does not capture all the information that is being presented in this one. I'm only included some of the ecological components and the energy components, along with economy and policy and infrastructure irrigation. So I'm actually looking from the supply side. This model provides a supply side review. I mean, how the production is being done, rather than focusing on the output side, which is like generating employment and other benefits for the society. So I have used systems dynamic modeling in this using Vensim PLE, and this is how the modeling was performed. So only these variables were used for the modeling purpose, and so we see that due to the policy allocation, there is a change in infrastructure which caused change in all the variables, like water energy nexus, which has effects on the economy, which again cause like the change in demand and the other things in the economy, and which again leads to a policy for allocation of resources. So it's like a complete feedback structure that is being captured in this work. This is the software that was used, Vensim PLE, and this is the place where you can download it. This is the main model. So since it's a very small one, I cannot explain all the variables into this one, but this is how the model was developed. Nearly, I had to build like 247 mathematical equations to generate it for just one of the crops, and then integrate it with the price mechanism for the whole region, and then run it forward. So this is something I will try to explain. The blue, okay, so there is a, how do you work? Okay, I will use my hands. Okay. So the blue arrows are the ones that are being simulated in the system, but we can see that the purple arrows are really important feedbacks into the system, which capture the economy network. So starting from the main production, we can see that the rain-fed area and the irrigated area are both contributing to the production. If both of them increases, the production increases. Moving a little upwards, we can see that the productivity, that is the yield. If that also increases, that increases the production as well. But if the production increases, then you have production increases on account of areas, then we see that the blue water demand also increases. So the blue water demand increases would lead to the increase in the energy requirement of for irrigation. But water is a scarce resource. So we need to allocate it for the energy production also, that is in the power plants. So if we are going to increase the irrigation, blue water for irrigation, it will have repercussions for the other sectors, that is the power generation and the domestic supply. So there is like, again, a catch-22 situation kind of being built up in the system. So that's why we need this study to see how much of water can be allocated, and that's why I am trying to develop this kind of work. So the blue water leads to energy, and then you have then there is like how much production you do, you will have a certain price allocate given to it, and how much of revenue would be generated out of it. So that will give me how much of return I will have from the blue water as well as the green water that is being used for a certain crop. So this is what I'm able to capture in my model, but I'm not using the price information in the bigger network, which actually change the prices of the commodities so that the return on these commodities also change in terms of water. Using the model, I'm presenting the results of the wheat sector foremost. So as you can see from the left side graph, this is the working of the model, and the arrow is pointing towards the actual area that is being reported in the region. Similarly, for the other graphs, the same kind of curve is actually pointed to the actual production in the area. The other curves indicate how much of contribution is coming from the rain-fed area, how much of rain-fed area, as well as the irrigated area. So this was showing me that the wheat is actually kind of decreasing over wheat production is decreasing over the years. So the water use in the wheat production is also expected to decrease, because the crop water requirement of is like taken constant from the water footprint network numbers, which is based on the crop watt model as well as the climate watt model. So these numbers indicates if there is change in the production of the commodity, then it will have effect on how much of water is being used in the commodity. So I get this another set of graphs which indicate how much of energy is being used for irrigation and how much of water is being used for the production, of which I'm also indicating how much of water is being used for as a blue component, as well as the other one being the rain component. These graphs indicates the statistics. This is the values for the revenue generated. So we can see that the total revenue is kind of getting increased because the price is getting increased in for these commodity. So this will also increase to the per unit water. How much of revenue is generated per unit water consumption. So we see that the blue water is actually going to return less on its used in wheat production compared to green water. So it makes more sense to go for less irrigation in this thing. But this is again like it's not connected to the higher model. So these numbers are less. Once you start optimizing it in the higher context of the relationship or the curve will become a little lower down due to the optimization that take place on behalf of prices. These are the graphs which are for the area and production using the rainwater harvesting structures. So this indicate that if the rainwater harvesting structure increase the production by 50%, of that is actually being given at the rain-fed areas right now. It will how the area is going to increase over time. Since I'm only taking into account the rain-fed area, so the irrigation water area under rainwater harvesting structures will go to maximum towards how much of it the rain-fed area is being allotted. But of course, this is a variable, so we can always change this variable in the system, in the model, and see what kind of change would be.
Sorry, Shelly, I will have to stop you.
Okay.
Thanks, time is up. Can you thank Shelly, please?
Right, thank you. Thank you, sir.
Questions?
Yes.
Maria?
Yes.
I thought it was kind of cool that you talked about rain harvesting. I'm wondering if you looked at what the percentage of people that have rain barrels here, or how else are they harvesting the rain?
Okay. I'm not doing like on a field site study in the region. It's more like if you introduce rainwater harvesting, how much of productivity increase can be expected in the rain-fed area. So if the rain-fed area is converted to rainwater harvesting structure at 5% per annum, so from rain-fed area to you go to rainwater harvested irrigation area at 5% per annum, how much of yield would be expected in that year, then in next year, and in that next year. So again, because even to implement rainwater harvesting structure, you have to have a price associated with building that structure. And I'm not really talking about how it is actually built on the field, but how much of money that goes inside it and whether it is actually feasible for the people to go for these kind of structures. So the monetary aspect is what I'm focusing about, not how they will do it on fields. Yeah. Yes.
Thank you, Shelley. I'm just interested in which areas you want to use this model in the future, or do you have any plans about that?
Any agriculture area which gives me enough data to run this model. I mean, because I made it like a very generic model, I just need the specific values for the region, how they are changing over time to run this model. So it's a very generic structure.
Thank you.
Yeah, thank you so much for the question.
One quick question.
Yes.
Yeah, thank you. Yes, I'm wondering about the parameterization. How many parameters do you have in this model, and how many did you have to find values for versus were already parameterized?
I think I needed something like 20 odd variables as the main parameters, and then I evaluated the rates according to those variables. But then I have also made some assumptions for these things because the data was not available, so I had to put in some values, but that I'm going to put in the paper in the whole discussion, and from there you can see, but I don't have the table right now to indicate that thing, yeah. Yes, that's it.
Thanks, Shelley. Can we thank Shelley again?
Thanks. Thank you so much, and good luck to all the people who are presenting tomorrow. Right. Bye-bye.
Okay. I've just been informed that Alan is not here yet. Is he here? Oh, all right. Yes, Alan, it's your chance. Yes. Okay, now the next talk is going. Have you loaded your talk? Okay, the next talk is by Mr. Alan de Barros. He's going to talk to us about individual-based movement models as a tool to assess statistical estimation methods applied to animals' movement. Thank you.
Just so. My talk will be about individual-based movement models, and the idea is to use these individual-based movement models to test some statistical methods that are currently used for to study animal movements. So in my PhD, I'm studying jaguars. I'm working with conservation of jaguars, and we are using these statistical methods to to assess the movements of jaguars, and we want to use the jaguar movements to think about ecological corridors. So it's important to assess how this movement, these statistics estimating the movement, how reliable they are, and how they compare with each other. So first, let's talk about movements. Movements are a key adaptive behavior, and they are related, like animals move to try to look for a better place where they can find more mates, where they can find more food. So movement is a key behavior for adaptive behavior, and this improves the fitness of animals. And not just animals, like even the plants, in some stage, they need disperse. So movement can be, we can think about movement in different situations. Movement also, when we talk about movement, we should think about scale. We should think about time and space. And scale, when you talk about animal movement, is very important. So we may get a scale in which the animal uses the area, and that we call home range. Then we may have animals that need disperse, and that we call dispersal. And we have sometimes the need of some animal or a group of animals to go to other locations to find food, and that is migration. So here we have some examples in Africa. So the thing is, movement is a critical thing for the animals, and understand movement is a critical thing to any action we want to apply to conservation, and even related to environmental policies sometimes, because we may, the animal that is focus of our interest could be insects, and they may be related to pollination, for example. So the idea is we need to understand the movements, because then we can evaluate better the impact that disturbances can cause on the animal behavior. And also, we can understand better which solutions we can come up when you have conflicts. For example, the elephants, they need water, and there is a very frequent type of problem that, like in Botswana and Tanzania, they have conflicts with elephants. They use, like for example, I just put a example, they use pepper, like to try to avoid the animals. So, but we need to understand how they move to try to come up with a policy. Also, fragmentation is something that is happening increasingly, and biodiversity is diminishing quite a bit because of that. The jaguar is one example, especially in Atlantic Forest. Atlantic Forest, we have now the worst estimates are 7% in the of area remaining, and for jaguars we have in any location we have less than 50 individuals isolated. So that is a very, very low number in terms of reproduction. So understand the movements, we can come up with better solutions to think about corridors. Then the thing is how movement can be connected with the challenges. And how can we solve these problems, like in biodiversity, like we're losing species, and how can use this knowledge also to propose strategies such as in the whole ecology, here like building wildlife passages, or even to come up with alternatives that are better. Like this is an example in São Paulo. They didn't do that because animals, but because this is high, we have a much lower impact than if this road was at the ground level. So just an example. Then we need to come up with tools that we can explore to analyze these movements. Individual-based models are one example of these tools. Can be applied to different things and also in movements. So the idea here is that I talked a little bit about movement already. So just to make more clear, one type of individual-based model is the individual-based movement model. And the idea is that we can, working with that, we can deal with multiple scales, we can simplify the complexity, and we can also generate insights, like in a controlled situation. And we have examples of that, even with Jaguars, like they create an individual-based model, and was in that context of road ecology to possible wildlife passages. So the statistical methods we are using here, they can be of two types. They can be the type that, calculates the probability between locations, and they can be a type that identifies suitable habitat. The data that we use on that, in general, come from the GPS collars, but that could come from any geographical location. So if you have that information from some band in the bird, or from camera trapping, you can also use that, but it's less accurate than GPS because you get more information. And the method that we are exploring more will be one of these statistical probabilistic methods that calculates the probabilities between locations. So this works creating utilization distribution, like probabilities between these points. So here you have that represented between 2 points, and then how that would be represented more points. And when we calculate a whole trajectory, we are going to come up with probabilities in the whole trajectory. There are 3 methods that I'm going to compare here. All of them are related. They are from this family that we call Brownian bridge movement models. The idea here is to do these estimates, this utilization density, but in the models that we call dynamics, they also account for some changes in this behavior. They're a little bit more flexible. They have some parameters that make that more flexible. And the third one has this flexibility and also account for some directional variance. I'm not going too much detail on this, but they are related, but one is supposed, like the third one is supposed to be better than the second, and the second better than the first one. So for this project, the first objective was to develop the individual-based model, so that we developed. Then apply this individual-based movement model, to these different statistics. And then we compare this different performance, varying the parameters for the movement. So when we come up with a very sensitive parameters, we can call that maybe a prototype of animals. So if we set the parameters very close to like a jaguar move or like insect moves, then we can call that prototypes. For now, I'm not calling prototype because we are comparing things that might be related with behavior, but we are basically changing the parameters. So it's one step before. A general outline for the methods then. First, we generate a heterogeneous landscape. Then we create the movement. And then we have this movement is based on some probabilistic rules. And then we compare the different methods. Like to do that, first we needed to sample the trajectories that we create, and then we define some parameters, and you compare how good these different methods perform. So first we create the landscape. Then we have the parameters associated with the model. I will explain in details then here. So this one is related to the distance of the movement, so the step lengths. So animals are more likely, like as a higher probability that they will stay in the same location or move low. Like few animals or at least in terms of behavior, they don't want to move that often. Yeah. So in terms of model, that's what we get. If you set a low probability, like the animal will move little. If you set a higher probability, the animal will move more. The other thing is like the directional variability. So that is how much the animal can vary the angle that he's walking. So in terms of model, this is like if we set 45 degrees, So the animal can go, like, has lower probabilities, very unlikely to go here. If you set 108 degrees, the animal can even go to backwards, like there is some probability for that. Also for habitat preference, the animals in general will prefer better habitat where they have protection, mates, food. They very often don't like habitats that are not good. But some animals are more flexible. Some animals can and that is what we get in terms of model. So if we set a very high probability for good habitat, the animal will really look for that good habitat. If we flexibilize that, then the animal can go in more places. And that will be closer to the landscape we have. Like if we flexibilize a lot, the animal can go anywhere, doesn't matter. So to do compare the methods, what we did was like we created trajectories. The idea is to do it with 1,000, but we had some computational problems for now. We did it with 100, and then we are going to, with 1,000, use the high performance computer later. But the idea here is we create this trajectory and we sample one point by point. And then when we remove that point, we calculate, we use that statistics and we calculate the probability for that. And we do that for all the points and we sum these probabilities. And then we can see which method perform better in terms of having a higher probability of estimates. Okay, I can go. And then, like, when we compare these different methods, like what I said that was a pre-prototype, was something like that. We've set a low step length, a low directional variability, low habitat preference. What we get in terms of behavior is like we have a short step length, the movement tends to be straight and to be more generic, like can go to more places. If we get, like you set high just for habitat preference, you have like the same short, straightforward movement, but the animal tends to go more to a good habitat, and so on. So we define the behaviors that would be connected with that parameters we are selecting. And I'm showing 5 examples. So this first one would be the short steps, generally straight, and more generic, like don't set in just one habitat. Like the specialist will try to be more time in the good habitat, but here also like short steps and generally straightforward. This one wonder more, like is more flexible in terms of angle, and although it's generic, like it's generic because it's not just in good habitat. But you see that because wonder more is short, it gets very clumped. And if you have long steps, then the animal can walk much more. And if it's generic, that will be more random. When we set a high probability, like these examples are the same. When we set a high probability for habitat preference, even if the animal can take long steps, that will tend to stay in the best habitat. So then we compare these different methods. One of them, like, is very computationally is very hard. So we almost finishing. So we just could do one run for that. But in general, like the second one and the third one in the literature, they are assumed to perform better. But here, what we get so far is that the second one, the first one. The second one is performing a little bit better. So, but in other 3 situations, the first one performed better. So we need to do more runs and some other statistical tests to evaluate that better. And that's just the final conclusions. The movements models, they may be useful tools for biodiversity conservation and other environmental management policies, and they can aid and test or offer solutions for different issues. And I'm planning to use that for my PhD and for jaguar conservation, but insect pollination or road ecology issues could be a good example of usage. Also, in this paper, in this work, we use this movement model to investigate the animal movements, but we can refine that to apply to more specific situations, different animal prototypes. One thing you noticed too, I didn't discuss that too much.
Sorry, Alain, I have to stop you. Thank you so much.
Okay, yeah, that
Right.
is the very end.
Yes,
Okay,
thanks,
so
thanks.
thank you very much.
Questions, Alec?
Thanks, Alan. I remember last time when you presented during the midterm presentations, asked something about season. Is it something that you take into consideration? And I see you still didn't mention anything about season, considering the fact that animal movement is also affected by the seasons, like in the Serengeti. I'm not sure of the Atlantic.
Yeah, no,
in Brazil.
Yeah, in this case, like the model we used are more simple, so we didn't put any parameter related with season, but that can be done. So probably if we consider some animal prototype, if that is a critical parameter, then that should be done. Now what we got is just like this movement that we have 3 main parameters that we can play with to estimate how good the methods perform. So far that was the objective, but for the next steps, that other parameters, including the season, we should consider and look for that.
Next question, David.
Thank you very much. I was just wondering how dynamic your model would be, because let's talk about sort of human settlements, because things are always changing in that environment.
Mm-hmm.
So if a road is built, then the movements would naturally change, even when you have the animal corridors, I would imagine.
Mm-hmm.
So how dynamic do you think it can become?
Mm-hmm. Yeah, I think your question is more the sense you are asking is not related with the dynamic model I put. Is that, or is just dynamic you mean in the context of? Okay, for these methods, these 3 that I use, they are not. They are just probabilistic. They just use the movement as a base to estimate the next steps. So in this one, probably like this difference that you are mentioning would not be taken into account. But for extension of this, I'm planning to analyze other methods that include geographical information, so the true habitat selection, and then that things would be taken into account. Yeah.
Last question. Okay, can we thank Alena? Emmanuel is going to be the last speaker before tea break, and he's going to talk to us about allocation of fishing effort among different target species in northeastern Hokkaido in Japan. Over to you, Emmanuel.
Yeah. Thank you very much for the introduction. We are now switching from animal, we're going to fish now. So, my topic is allocation of fishing effort among different target species in northeastern Hokkaido, Japan. If I had to ask you, is there anybody who don't know fish? Yeah. Is there anybody who have ever been fishing? Or do you know the process to get your fish on the plate? That before having a fish, there is an effort to get a fish. And that is the allocation of the target species of fishing effort. And in case of mixed fisheries, that means where one fisher can target more than one species, or in an area they target more than a species. There is allocation of species, and that is determined by different factors that I'm going to talk on now. So to start my presentation, this is the outline. We start with the introduction. I talk about the general introduction, rationale of the study, but also the objectives, but also the material and the methods. And this will be the overview that we are using models, so the mathematical model we are using, but also the model description, as well as the model parameterization. And this will be followed by results and conclusion. So, there is a lot of studies going on climate change, and in particular also on fisheries. As we know that the oceans, the sea, they cover more than 70% of the total population. But this environment, it is affected by climate change. And this also, they affect the catch of different species. But also, when we talk about the social aspect, and particularly in Japan, as we look from the population pyramid, as now, the population of Japan is aging. And if you know that Japan is surrounded by the ocean, that means the fishermen, they are also aging. So when you talk about sustainability, it can be in terms of biomass, but also it can be in terms of the fishing labor. So how would it be in the future? But also this can affect the allocation of species, that maybe the aged population can bias or can target one species, and this has an impact on the ecosystem. But also, we all love fish, we all love food. And Japan, but 40% of the protein comes from fish. And the fish consumption per capita is like 40% by now. By oil, when we talk about beef, is like 5%. So it covers a big portion of the diet in Japan and also the world, but also the economy. The Japan, the catch is more than 40% of the world. So you can see how important the fisheries in Japan, and particularly on the third area I'm going to talk on now. So why do we need to study, to examine mixed fisheries? This is because we need to understand how allocation of fishing effort for different target species, it can affect the social component, also the ecological component, as well as the economic component. Yeah, so there are different kinds of species. This is salmon, it is trout, and many, many other species. So understanding the allocation of targets of effort among species, it enables us to improve the fisheries management of a place. Therefore, this is my study area, and this is Japan, neighbors oceans, and I'm talking about the Pacific Ocean, where my study area is, the Akechi and Elimo in Hokkaido. So here comes the statement, the problem statement of my study, that now there is a global transition in fisheries communities. And this is in terms of the social, whereby this is the shrinkage of population and the age of fishers, particularly in my study area. But also, there is economic dynamics in the place, that the increase of population cost, this is caused by the oil price is increasing, labor, but also we needed to buy a new boat or to need to do some maintenance of the boat. And that is as an effect also. Also, ecosystem, that targeting of one species at a time, it can lead into depletion of stock abundance. And as you know, understanding how many fish in the ocean is very difficult. So it is ambiguous. So we needed to understand so that we can come up with a critical management goals. So looking at the catch and income in my said area, you can see from 1960s, they used to target Pacific herring. But as time went on, there was changes. You can see this, the red line shows the salmon, but also the black, the carp, and this shows the oyster. And this is you can say the main target species in Akechi. But also, looking on Elimo, we have the same salmon, we have the carp, also the contribution here, but also we have the whelk. So when we are trying to start the allocation of effort, so we are looking on how the species, they contribute in the catch, but also in terms of income. So moving forward, these are my study objectives. First, to examine how fishing effort is allocated in the area, but also to investigate the effect of economic and the biological drivers on the fishing effort. And the third one is to predict the effort of allocation among target species in the future. So moving forward, we have 4 species of our stud, 3 species in each area. So in Akechi, we look on the oyster, also seaweed, and the salmon. Whereas in Elimo, we look on 3 species, the seaweed, salmon, and the whelk. Therefore, the seaweed and the salmon are shared between the 2 areas, but also different species in 2 areas. So we are using the integrative mathematical models, and this we are using 2 types of data sets. So we are using the data from the Fisheries Cooperative Association that is mandated for the management of local fisheries, and we got data on the demography of fishes, but also the ecosystem, that means the catch, as well as on the socioeconomics. But also, we did the questionnaire survey, and we have the data on demography, also on the income, also how fishermen, the contribution of species in the total income. And this model, it links the biological and socio-economic dynamics so that we can have a robust prediction and management. Also, the prediction of fisheries, any transition in traditional fisheries is very important to have a wide range of data. And this is our study trying to cover many data. So, the model state variables. So we study from stock of biomass, that if we have stock of biomass and we apply the fishing effort, we will catch fish. If we catch fish, we expect the price of fish might change. But also, the catch and the price will give us revenue of the fishery industry. But from the fishing effort, it can give us the cost, so the operation cost. And the operation cost and the revenue will give us the profitability. And this profitability, it can also affect the allocation of fishing efforts. So this how we are using so that we can have the good understanding of the situation. So the parameterization of the model that we use in systematic regression analysis or fishing operation cost on effort fraction, but also the price of catch, the price on catch of the 3 species in each area. But also, for the estimation of model parameters, we are using the direct estimation of parameters, also fitting the models. So fitting the models, it gives us the result, this result. So the y-axis shows the catch in terms of time, but this the x is time in terms of years. So we can see this is a 35 years simulation. And the blue shows the observed data, but also the red shows the model estimation. So we can see that for the three species, the salmon, oyster, and the kelp, that our model is robust in terms of prediction. So this is a good step towards the development of a good model. But also, looking on the change of fishing efforts, where on the y-axis is the fraction of effort, and this is time. So we can see the kelp makes the high composition of the effort, while the oyster and the salmon is low. This in terms of Akash. So, and this is a quite interesting study because it's consistent with the questionnaire survey, that it shows that the model predicts that the fishing effort is allocated primarily to the kelp and the rest to the salmon. And also, there is a slow change in the fishing effort between the species. So looking on the long term, this was like 1,000 years, trying to see how this will be allocated. So from here, the red point shows the starting point. So this is the starting estimate point. So the allocation of effort from here, so it goes around changing with time, and this depending on the variation of the stock of biomass, but also the profitability of the species. So the same story that the kelp is more targeted compared to oyster and the salmon. So moving forward, this comes to the conclusions. So far, what have the results tell us about this study is that there is a slow change in fishing effort among different target species. And this also, it might be more affected by the biomass. That as the biomass of the stock changes, so there is a less alternative for the fishermen to switch between species. But also, fishers are likely to target more species that have high abundance and profitable. It doesn't matter, maybe you catch a lot of fish, but if you catch a lot of fish and the price is low, for them it makes no sense. That's like a loss. So this also is the finding of our study. But also, it is very important that at this point, because this allocation of fishing effort on different species, so it's very important for the management to try to control the effort allocation so that we can have a sustainable fisheries and also profitable fisheries. So what will be the next step? The next step of the model, and now it's not part of our study, but our model can be extended to understand the long-term change in fishing efforts with many number of target species. Now 3 species. So if you add more species, because the areas they're targeting a wide range of fish species. So trying to, if we put more species, how will it be the allocation of fishing species? But also, the effect of fisher demographic dynamics allocated to fishing is very important, because with the assumption that different age, different age of fishers or fishermen, they might target different species. So it's very also to understand this trend. But also, how the climate change, we have seen that climate change has an effect on the fisheries. So also very important to understand. So if we compare in the model in the future, that how the climate change in the future, it can affect the allocation of effort, but also the management and the situation of the fisheries in the area. So having said that, makes the end of my presentation. Thank you very much.
Thank you, Emmanuel. Questions to Emmanuel? We can ask him if he knows fish.
Thanks, and thanks for staying on time, by the way. So, what is effort? Is that what we would generally call quotas? Because you didn't define that.
Okay. Yeah, it's not quotas. Because if you say quotas, is the allocation of the maybe amount of fish that can be harvested in a certain area. But here, the effort is including the number of fishermen targeting that area, but also in terms of fishing, for example, number of fishing boats, that how the fishing boats, the number can change in the area. That how many fishing boats in this time they are targeting this species in that particular area. But now, of course, it is measured in terms of years. So the variation in years, how is going to affect the allocation of the fishing effort.
Thanks, Emmanuel. I'm just wondering, are these target species pelagic or demersal? And what kind of fishing trawls do these farmers use?
Yeah, for salmon is the wild capped fisheries, and it is mostly harvested by set nets, but also by gill nets, and is almost done in spring and summer. But talking the other species, for example, the oyster. The oyster is the farming species. That means you put the seeds in the sea, and they grow naturally in the sea. You see, so that means you put them in you dip them in the water and then you take them. But for the kelp is a seaweed. So you just go in and collecting. You collect it, and the growth is very fast. So that's how it is done. And for the whale is more or less the same with oyster. Did I answer your question? It is maybe set net. Set net, that the net is set in the water, and it can stay for like a year or 2 years, and then removed, cleaned, and repaired like that. So it just set permanent. But for the gill net, it can be set maybe seasonally. You set it there, and then you go maybe in the evening or in the morning. You go, you take your fish, and then you dip it, just so like that.
Thanks. Can take last question from Charles.
Domo arigato gozaimashita.
Doitashimashita.
Asante sana. Whatever. I just wanted to know, in terms of your data sources that you used, or that you plan, or that you have used in this research, is it mostly secondary data, or is it how have you been collecting the data, and what's the nature of the data, what's the status, accuracy, and so forth of the data used?
Yeah, so we have two sources of data sets. The one is from the FSA, and the FSA is very powerful in Japan. It's the model when it comes to fisheries. And the FSA actually is mandated that every fisherman have to be in a fishing, in FCA. So you go to fish in the morning, you bring your fish, their weight, and they are recorded, also how much they catch, but also the revenue. So all the data are recorded there for a long time, used from 1965. And they are good. We can trust the Japanese. They are smart. Yeah, and from that we get the catch data, the income, and from there we can get the price, but also the number of fishermen and so forth. But from the questionnaires, this is an interview. We did an interview with the fishermen to try to understand the historical information of that fisherman, for how long has been fishing, the fishing experience, but also trying to ask if species A goes distinct what will be the next stage? So that is very important for us to understand. And that's why there is a consistency between the model prediction and the data from the questionnaires. Yeah.
Can we thank Emmanuel again? And this brings us to the end of the first session. We're now going to take a 20-minute tea break. And then I would like us to be back by just before 20 past. We're going to start at 20 past. Thank you so much.